Good Thursday, and welcome to the walkthrough for our this week's assignment. This week's assignment is pages 207 to 208. It's an inquiry lab, slope triangles, and it is due in the Google Classroom on May 8th, Friday. So let's get started. How does graphing slope triangles on the coordinate plane help you to analyze them? Well, what is a slope triangle? It has two parts. It's got the slope part, it's got a triangle part, and we're going to build these with slope. What do we know about slope? It's rise over run, or the change in y over the change in x. So it changes for amount of y, and it changes an amount of x. And what do we know about triangles? Well, in this case, if you look at this type of triangle, it's a special triangle. It's a right triangle. Right triangle. I should draw the triangle correctly. It's got a right angle. It's got a 90-degree angle in it. That's what makes it right. So if I can look at slope in terms of a coordinate plane, another big vocabulary word, this is a coordinate plane. It's got horizontal and vertical lines. So it lends itself to finding locations and moving from point to point by moving vertically and horizontally. So we've already got a lot of things that we know about this shaded right triangle here. And then we go on to look that Dante ordered the plans shown to build a skateboard ramp. Okay, so this is a skateboard ramp where you're going to skate up the ramp to the end. And each unit represents 1 foot, okay? Each unit is 1 foot. He wants to keep the same slope of the ramp, and extend the base, that's the bottom, of the triangle by 3 feet. How tall will the ramp be? That's your question here. Okay, let's take a look at this triangle that they've drawn here. How do I get from this point right here to this point? How do I get from this point that's at 0, 0, we'll call it A, to this point over here, which is at 6, 2, which we can call B? Well, how do we get there? We need to go up. As a practical rule to keep it straight, I tend to do the vertical component first, the rise or run, because it's in the numerator, and then I tend to do the horizontal component. So how do I get from this point to this point? By going up 2, and then I go to the right 6. So now I know my slope of this line. The slope of this line is rise over run, which is 6. Rise is 2, pardon me, and it runs 6. Well, what do I know about this 2, 6 here? I can reduce 2, 6. They share a common factor of 2, and when I reduce that, I get 1/3. So this triangle should also rise 1 and run 3. Rise 1, 1, 2, 3, and it does. I see that it catches here. So then it'll follow that pattern. Rise 1, run 3, rise 1, run 3. The next one would be rise 1, run 3 over here. If I was to extend this triangle out, where is this located? At, well, the x-coordinate would be 9, 3. And if you think about this, he wants to extend the base by 3 feet. How high? So this is 3 feet. So how high is it? Would be here, the height. And you have the answer. The height of this corresponds to the y coordinate. Okay, let's take a look at it step by step. Refer to the graph shown above, which we just analyzed. Triangle ABC is formed by the rise, the run, and a section of the line y equals 1/3 x. This slope here It says it's formed by the rise and the run. That's the rise part, the run part, and then the line part. Well, the line part is the in a right triangle is the hypotenuse. And the rise and run part are the legs. This is going to be important when we get to the Pythagorean theorem and right triangles. But it's very important to understand and refer to the right parts of the right triangle as leg, hypotenuse. Practice that because it's going to come up a lot in high school. So we want to graph this y equals 1/3 x on the grid paper. Okay, look at this equation here given y equals 1/3 x. Notice that there is no trailing number here. We know that y equals mx plus b is slope-intercept form, where b is the y-intercept. And in this case, there's nothing here, nothing trailing here. So it's 0. So the y-intercept on this line is going to be 0b, and in this case, b is 0, so it's at 0, 0. So we need to start at 0, 0. And then we have the slope here, 1/3. So from 0, 0, the starting point, we're going to rise 1 and run 3. Rise 1, 1, 2, 3. Rise 1, 2, 1, 2, 3. We got it. So we have this line here. We're not going to draw, we're going to draw a line segment because we're going to box it off. Draw a right triangle. Now, how do we make the right triangle? We need to do the rise component and the run component. So let's draw that in there. There's the rise part, and here's the run part. And that forms a right triangle. So we've graphed this on the grid paper. We need to use a point A, 0, 0, and B, 6, 2. So let's put that on there. A, 0, 0, B, 6, 2. So we've recreated the triangle that we've seen above. And what is the slope? Well, we know the slope is 6/2 because, I mean, what's 2/6 because the rise is 2, run 6, but let's reduce it and use the smallest amount. And we have it from the equation too, 1/3. Select any two different points on the line and then label them D and E. So we can continue this out. Let's use a pencil. I'm going to continue this out. This pattern goes rise 1, 1, 2, 3. Rise 1, 1, 2, 3. Okay, so I went off the grid paper. And here I go down 1, 2, 3. I could go the opposite direction. So I'm over here. I'm kind of off the grid a little bit. It's got to be on the same slope. So there you go. I'm going to terminate it there, right here and right here. So draw two different points, label them D and E, and draw another triangle from these 2 points. Okay, so let's call this one D. We're going to call this one E, way over here. This point is located at 1, 2, -3, -1. And this point's going to be 10, 11, 12. And if I go over here, it's going to be 12, 4. And I have to finish the triangle. Vertical line. I don't have a ruler with me. It's a right triangle, and there you go. You have a new triangle. Is the slope of line segment DE here the same as the slope as AB? Doesn't it rise and run at the same rate? So you need to answer this question with an explanation of why these slopes are the same, and use the vocabulary, use rise and run. Talk about the hypotenuse, or talk about the line or the rate. Okay. Part 3, Step 3. Dante wants to expand the base of the ramp by 3 feet. Graph and give the coordinates of the point that will represent the extended base of the ramp. Okay, well, we can do that. I have another marker here. I'm hoping it's not. I have a black pen. And if I extend this by 3 feet, 1, 2, 3, here, 3 more feet, so it's at 9. And then I go up, I can see I've already put a dot there. So now I've got a new right triangle. I'll do it in black. There's my new right triangle. Graph and give the coordinates of the point that will be represented at the base. So it's graph, give the coordinates of the point that will represent the extended base of the ramp. So we need this point right here. Let's see, we've used A, B, C, D, E, so we could call it point F. And where is it located? It's located at 9, 0. Create a right triangle using the line in that point. So we already did that. What will be the height of the new ramp? That's what this is right here. We're looking for the height, and you can find that now. Okay, feel free to pause the video if you need to look at this longer to answer your questions. And then resume the video and turn the page. We go on to this investigation. Working with a partner, we're doing remote learning, so you won't have a partner, but feel free to get on the electronic device with somebody else in the class. Draw 2 right triangles for each exercise using the rise, the run, and the portions of the line. So we need the rise and the run. And you're just using a portion of the line. It's better to say line segment to use the right language. Draw 2 right triangles for each exercise. So you're doing 2 right triangles for each exercise. Okay, well, first you have to be able to graph the line. And you need to use y equals mx plus b, the slope-intercept equation. Where you start at 0b. So the trailing letter over here, you're going to start at 0, 2. Okay? And now you need to also then move by the slope. That's the rise over the run. So you start at 0, 2, you're going to put a dot, 0, 2. Okay. We have a slope here that it's the number in front of x, the m. Slope is m. And now we have no number there. So isn't the slope -1? Because there's nothing there, we always put a 1 there. But the problem is I need a fraction. So I need to go -1 over 1. Now it's in a fraction. I have a rise component and a run component. The rise tells me up or down. It's negative, so it's down. The one in the denominator is 1 for run. That's right. Okay, so from this dot, I need to go down 1 and right 1. And I continue this pattern, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Now, I want to go the other way. So I can move that negative sign. I can put it in the numerator or the denominator. It's also equal to +1 over -1. In this case, I'd go up and left. So I go up 1 and left 1, like that. Up 1 and left 1, like that. And now I have a line here. I'll draw it with my... That's your line. Now you need to make 2 triangles. Well, I'll make one. I'll help you make one. Let's start here at -1, 3. And we can go all the way to here. That's 1 triangle. So if I want to go from here, I'll call it A. And I'll call this one B. B is at 3 negative 1. Oh, look at that. Negative 1, 3. So, oops, I missed. Try it again. So I've got a vertical component. I need to make a horizontal component. Now I have a right triangle. So I've built a slope triangle here. Now you need to build, that's one. You need to build two of them. So you could find another dot, and any dots work. You could do a real small one. What do we know? Well, a follow-up question for this would be, why are these if you draw multiple triangles in here, are they similar to each other? Similar, what is similar? Same shape, but the legs are not the same size. They have the same angles, but the legs are different sizes. Part 3, make a conjecture. What do you notice about the shape and size of the pairs of triangles in each exercise 1 and 2? Well, what you'll see this pattern here, and then what do you notice about the shape? So there's two parts to this, the shape and the size. We talked about the shape just a second ago. When you talk about shape, you're talking about angles, so use that language. And size, you're talking about length of the sides of the triangles. Angles are formed in the corners. They're all going to have what kind of angle? What's this box mean for a right triangle? What does that box mean? And what is this and that angle? Okay. You can even give the degrees of the angles if you want to get sophisticated. And now we go to 4. Use math tools. The triangles in this activity are called slope triangles. Complete the graphic ordinance by writing the 3 observations. So 3 observations here. 1, 2, 3. You just described the angles of the slope triangle. So maybe talk about angles here. You could talk about similarity. How do you write the word similarity? S-I-M-I-L-A-R, similar. And if you're talking about 2 similar triangles, you could write it like that. Similarity, you'd add an I-T-Y. And that refers to same angles, different lengths. You could talk about the slope. So 1, you could talk about the slope of slope triangles. You could talk about similarity, or you could talk about some other thing, and then you want to define what a slope triangle is. When you do your definition, you need to talk about the legs and the rise and the run. And then you could talk about the equation of the line, maybe having to deal with slope, and in some cases, the y-intercept can change. So you're still starting everything in the same y-intercept. The slope is going to be the same for all your slope triangles that you're making within that confinement. Okay. 5. How does graphing slope triangles on the coordinate help you analyze them? Okay, when you talk about slope, you're talking about steepness, you're talking about flatness. So how does that translate in the real world? If it's a steep line, a positive steep line, very high, it rises a lot and runs a lot. Think about it like pay. If it rises a lot and runs a lot, and this is the hours going along the x-axis, and this is pay going along the y-axis, what does it mean to rise a lot and run? So if I rise 10, that'd be $10, and I run 1, that's 1 hour, right? So am I making a lot of money compared to a very flat slope where I rise for $1 and I run for 10 hours? I'm only making $1 for every 10 hours. That's only 10 cents an hour, right? Where I'm making $10 an hour. So you could imagine even steeper where you wouldn't have to change the x and y axis. Let's say it rises 100 for every 1 hour. That would be like a lawyer or a doctor makes about $100 an hour. So think about that as you answer number 5. Get that turned in to the Google Classroom, and good luck.